case something else is going on in the background.
Sorry.
All right. Okay, so today we're going to start with anatomy and physiology. Very, very interested. We're going to cover some topics related to the previous class that we had, that we talk about the systems and the medical terms. So certain things are going to be kind of familiar with you. So familiar with, not with you. So that's basically what it is. So we're going to start with the smallest particle of a living particle of our body, that is the cell. Remember, we're going to talk about anatomy and physiology. The first thing that you need to understand is anatomy are the structures of our body. Anything that you can see, anything that you can touch, that is called anatomy. Physiology has to do with the functions. Whatever functions these structures are providing to the body, that is called physiology. So when a patient goes to the medical doctor, immediately the patient complains about something if they are suffering about something. So they'll tell us something about the structures of your body, what they're feeling, what the symptoms are. The medical doctor is going to review all, is going to do physical examination and is going to evaluate certain parts of the body. Then he's going to come out with a conclusion, which is a diagnosis. The diagnosis is nothing else than the functions of that particular part of the body that the patient is complaining about. So we have structures. When those structures do not function properly, we are going to develop medical conditions. Patient is going to develop symptoms. There's going to appear some signs. Remember, symptoms is what the patient feels about something going on in their body. I have a pain in the back. That's what they think. Now we need to know where is exactly the pain? What is causing that pain? Which structures are not working properly that is causing the patient this pain or this inflammation or these scars, marks, lesions, whatever the case may be. So whenever we talk about anatomy and physiology, that's what we do. We're going to review those structures of the body that are called anatomy, and we're going to see how they function, whether they are function normally or abnormally. So the first thing that we're going to do, we're going to talk about these smallest particle of the body that makes up the body. These are the smallest living structures of our body, which is called the cell. So let's begin with that. It says right here, it is the smallest basic living unit structure of our body. We have different types of cells, and we have different sizes of cells, different shapes of cells. Of course, each group of cells from this particular organ of system, they're going to have different functions. Think about this. What are the cells that makes up the bones? There are particular cells there. We're going to go through that. The cells that works, the functions that they provide to the bones are totally different from the cells that makes up the skin. The skin has other type of cells that it's made of, but their functions are different. What about the cells that makes up the brain? They are totally different in shape and size versus bone cells, muscle cells. Why? Because they are different, because they are provided different functions. The functions of the bones are not the same as the skin, are not the same as the brain. They are not the same as the internal organs, and so on and so forth. So for that reason, we have different type of cells, because these type of cells get together to make a tissue. These tissues groups together with the same characteristics to make an organ. See, the heart has different functions than the liver, the pancreas, the intestines. So it's not the same, because each structure is made of different cells because they have different functions. So that is what we are going to talk about here regarding the cells. Here we have certain cells, different shapes. As you can see right here, we have some of them that are round or kind of circle and circumference, some that are elongated, some that are square, some of them that we don't even have a name to describe them. Why? Because they are irregular, have different shapes. Here we have other type of cells. So here we have cells, here we have cells. So depends of the system that these cells belongs to. They have different shape, different size, different function. This is like, think about a company. Depends on what is the services that this company is providing. That's the body. Company is a complete body. Body has a owner or a society, people that owns this particular company. They have supervisors, they have CEOs, they have employees, they have employees in different departments who has different functions. It's the same as the body. So once again, that is the importance about talking about the cell, because these cells are the smallest, remember, living organisms. Living, meaning they have a life. So we need to know about the cells, because then we're going to talk about these systems, and each system is going to have a different function because it's made of different cells. The same cells that groups together to make this particular system. So each system has a different type of cells, different sizes, different shapes. That's basically what we need to understand. That is the cell, the basic unit of the body. But in national certification, usually they ask you which is the smallest living organism of our body, the cell. That's how it works. Here, let's talk about the parts of the cell. A cell has three parts. Now we're going to mention it right here, and then we're going to describe, we're going to give a little definition of what is it. What's the function of each of these parts? What do they contain? What is that made of? So we have the cell membrane. So the cell membrane is this membrane that protects the content inside the cell, just like anything else. We have a membrane that protects all the internal organs, the skin. So all the skin is like a membrane that protects all the internal organs. Can you imagine without the skin, we will be able to see the heart, the blood vessels, and of course, will be a greater risk of damaging these organs because they are exposed. So the cell membrane protects the content inside. Later on, we're going to discuss other functions. Then the cytoplasm, this is the content inside the cell membrane. Here, there are liquids and solids. There are some organs, but they are so small inside the cell because the cell is microscopic. So inside the cell, we're going to find organs, but because these are so small organs, we're going to call them organelles. We will go over this as we are moving forward with the chapter. So the cytoplasm is nothing else than liquids and these smaller structures inside the cell. Then we're going to have something else, the nucleus, which is this blue part right here, which is the brain of the cell. It's like the head on the body, the nucleus. So we have the cell membrane, the cytoplasm, and the nucleus. These are the three major parts of the cell. Remember, each cell, regardless of the size, regardless of the function, regardless of the shape, they have the same parts: cell membrane, cytoplasm, and nucleus. Let's define the cell membrane. What is the definition? It is the outer layer of a cell, or the outer boundary. Remember, it's the one that protects the content inside. Think about our skin once again. The peel or the skin of an orange, or the shell of an egg. It is the protection on the outside to prevent things that are inside from spilling out, so to speak. So that's basically what it is. These membranes allows certain things to go in, certain things to come out, because this membrane has little pores within, just like our skin. The little pores where when we kind of transpire or sweat, if you will. So this membrane is not completely closed in. It has little pores. And through those little channels, things goes inside. The nutrients, they have to go inside. This is a living organism. So the cell receives nutrients from the bloodstream, minerals, water, sugar, fats, vitamins, proteins, hormones. But then when all these nutrients enters inside the cell and are consumed, they need to leave the cell. So it removes the wastes as well. So those little pores within the cell membrane is called semi-permeable membrane. Semi means that allows certain things to go inside and others to come out. Remember, nutrients needs to go inside the cell. Wastes of all these nutrients needs to get out through these little pores through the membrane, the cell membrane. Now, there are certain things that can come out, some others cannot. That's why the cell membrane is mainly made of lipids and proteins. Remember, lipids are fat. Fat does not allow certain things to go inside the cell or certain things to come out the cell. because most of the things that we have inside the cell are liquids. We are not allowing the liquids that are inside to come out, because then the cell is going to die. So the cell membrane protects the content inside, allowing certain things that we need inside the cell to go through the cell, and things that we don't need in the cell, which are the wastes or excess of something, to be removed. Just like in our body, this is a tiny living organism. That's basically what it is. So things that you need to know: three parts of the cell membrane. What is the purpose of the cell membrane? Allowing things to go inside the cell, others to leave the cell. Particularly, nutrients are going to go in, wastes are going to come out. That's basically what it is. Simple. In a basic way, that's what you need to understand. Questions for the exam. How many parts the cell has? Okay. And little by little it says this is the membrane that protects the cell. What is called? Oh, the cell membrane. Just like that. They're not going to ask you questions that are too complex. It is simple. Sometimes they don't even ask about this. But for you, you need to understand, because we are going to cover other topics that are needed this information so you can understand what's really going on. The cytoplasm, this is the content that it is within the cell membrane. Now, one more thing, the cell membrane gives the shape to the cell. Depending on what is the content inside, the cell takes different shapes as it fills in with all these liquids. Because we saw already that I have some images there, some different shapes of the cells. So not all the cells are the same shape. So it says right here, the cytoplasm consists of organelles. Remember, organelles are tiny microscopic organs. We're going to discuss about them. So the cytoplasm, it is made of cytosol and organelles. What is cytosol? The liquids, the fluids inside. So cyto is the fluids, and the organelles are these tiny structures. We're going to mention those structures as we move forward with this chapter. We're going to talk about those structures that are very fundamental for the cell's functions. So that's basically what it is. So usually you are not asked about, okay, what is the cytoplasm? No, it's just that you need to know the parts so you can put everything else together. That's basically what it is. Now, let's talk about those organelles. See, now we are going to talk about the ribosomes. These are not the first, not the second. No, this is just one of those tiny solid structures that are found inside the cell, within the cytoplasm. So what is the most important thing about the ribosomes? They synthesize proteins. So that's the only thing that you need to know. Do not worry about anything else. The ribosomes synthesizes proteins, meaning they manufacture the proteins. They take proteins, they take all these chemicals, and they make up proteins. That's how important it is. So those are the ribosomes. Now we have other little structures right there, like this one. See? They are very tiny. Remember, the cell is microscopic, and these organelles are inside the cell. So we have something that is called the endoplasmic reticulum. What is it? As you can see here, there are a bunch of sacs or canals. What do we need all these sacs or canals inside the cell? To transport all the nutrients inside the cell. Just like the pipes, the water pipes inside the cell. So things goes through these channels from one structure to the next. And it stores whatever is not used. So that's basically what it is. The endoplasmic reticulum are these sacs or canals that they use as a medium or track or transport. Once again, whatever is not being used by the cell, it is safe in this sacs. Like let's say we didn't use all the sugar, all the fat, all the proteins, or we're gonna keep it there. And when it's needed, we're gonna distribute it to all these little organelles inside the cell. That will be the endoplasmatic reticulum. Now, remember things that you will be asked on exam: ribosomes. Why? Because we need to know where are proteins synthesized. So that's important. Moving on, mitochondria. These are definitely 100% questions for your exam. What is the mitochondria? This is the powerhouse of the cell. This is the cell that produces energy. This is the organelle that produces energy inside the cell. So, question for exam. Which of the following structures is the powerhouse of a cell? Mitochondria. Which of the following structures are the energy producers or generators of a cell? Mitochondria. If I said the powerhouse of the cell, what is the power? Energy. Energy. So we're gonna make it very simple. Mitochondria, powerhouse. That's it. Energy. As soon as you see energy of the cell, powerhouse of the cell, they're talking about mitochondria. If they are talking about proteins, as soon as you see the word proteins, then you know that it generates proteins, it synthesizes proteins, ribosomes. Ribosomes. That's how you need to understand this, because it's not about explaining and giving all the details about the functions of the mitochondria or its shape or how many do we have. Not related. So these are the things that you need to kind of keep in mind all the time, because you're only gonna need this for the exam. After that, nobody who's gonna remember about mitochondria, because the job that you're gonna do does not require for you to be using these terms over and over. For the exam, yes. Any questions about these organelles that are within the cytoplasm, inside the cell? Ribosomes, mitochondria. Forget about the endoplasmic reticulum. That never comes up on exams. It is important for the cell, yeah, but that's not what is considered important for an exam. Lysosomes. This is another term that comes in exams. So what is it that you need to understand about the lysosomes? This is the digestive system of a cell. So this is like the mouth, the pharynx, the esophagus, the stomach, the digestive, the small and large intestines. They are the one in charge of digesting proteins, carbohydrates, bacteria. They eat everything. They break down everything. So they are the digestive system of our body. So questions for exams. This is considered the digestive system of the cell. Lysosomes. Be careful, it's not ribosomes. They sound alike. Ribosomes, remember, they have to do with proteins. Lysosomes has to do with the digestive system. So that's what you need to understand. They're not going to ask you anything else. It's just its function. What are we using lysosomes? What is the function of the lysosomes? Oh, the digestive system of the body. That's it. Very, very simplified. I'm not going to put in your heads so much stuff that then you can barely remember. But if you have few things that you need to remember about each one of these structures, it's going to be a lot easier to retrieve this information later on, at least for the exam. Anything else? Once again, you're not going to need this. Well, let's talk about these movements of substances across the cell membrane. So remember, let's assume that this is the cell. This one right here. Oh, where's my? Let's put it a little thicker so we can. So let's assume that this is a cell. And what I'm drawing right here is the cell membrane. Something needs to something needs to enter the cell, something needs to leave the cell. Because remember, this cell has little pores right here within. So things can go in and out, but it's so small, the cells, the things that are too large to pass, they're not going to pass. Things that are liquids, they are difficult to be removed from the cell because this cell membrane contains one layer of fat. So remember, fat, water, they don't get together. So usually they don't mix. Usually this membrane don't allow liquids to seep out the cell, nor enter the cell. Think about our skin. Our skin contains a lipoprotein layer. That's one, when you take a shower, water doesn't go through your skin, or the liquids inside your skin, our body do not come out through the skin either, unless we're sweating because we are doing lots of activities because of the sun or whatever. The same happens with the cell. So there are some things that are going to enter very easily. Some others are not, but they're going to need something that is going to transport them from the outside to the inside and from the inside to the outside. So let's see which type of modes of transport to the cell from the cell. So we're going to have something that is called physical or passive process. Passive transport. So we have passive and we have active. So one of the good things that we have about science is like one thing is opposite to the other one. See, if it is cold, also can be hot, the opposite. If it goes up, also can come down, front, back, top, inferior, superior. So we can deal with all this in a better way. So things that you need to know about transport. Not that you need to know all these per se. It's just for you to have an idea how these nutrients enters the cell and how the waste leaves the cell. That's basically what we need to know. So whenever we have a passive transport, means that this transport does not use energy. There is no energy involved. They just do it by inertia. So do not require energy. But the energy that we use inside our body is called energy, is called ATP. What is ATP? Stands for A is adenosine, T tri, P phosphate. So we have some proteins, some enzymes that are called adenosine and 3-phosphorus. It's a combination. Nobody's going to ask you about this. But the only thing that you need to know that the energy that our body uses is not the electrical energy. This is an energy that is generated, remember, by the nervous system. And this energy is just there. So there are some things that requires energy for their functions, others, they just happen. Simple. So passive transport is divided in 3 processes: diffusion, osmosis, and filtration. You heard about filtration? We filter water. We have a filter. The coffee makers have filter. So lots of stuff have filters. But the diffusion of the osmosis are a little different. We're going to talk about this. So which processes of transport do not need energy? Passive transport. But which ones are those processes? Diffusion, osmosis, and filtration. We're going to discuss that later on in this chapter. Now, passive, this is active transport. What is active transport? Well, one of the major things about active transport is that requires energy. When you are doing exercises, it requires energy for you to do those exercises. But if you are just sitting in the couch, like I'm doing right now, sitting in a chair, just opening my mouth, I don't require much energy. Here, these processes requires energy. Which active processes requires energy? Endocytosis, exocytosis. We are going to define these terms next. So we're going to talk about diffusion. What is diffusion? What is osmosis? What is filtration? What is endocytosis? And what is exocytosis? This is important for us to understand how the processes in and out the cell works. So that's basically what we need to understand. So let's move on right here with these two types of transports. Remember, movements of substances into and out of the cell. We have some particles, substances that enters the cell, leaves the cell, that do not require energy. That will be diffusion, osmosis, and filtration. We have other processes within and out the cell that needs energy for this to happen. That is called endocytosis and exocytosis. We will discuss them individually so you can understand a little bit how this works. Okay, so diffusion. So what is diffusion? Very simple. These are the movement. You don't need to learn that this is the movement of atoms, molecules, ions, because this is too much information. So movement of substances from a region of high concentration to a region of lower concentration. That's it. No energy required. So there are lots of these substances outside of the cell, less inside the cell. That's what it's saying. We have something outside that is higher concentration, and it needs to enter a lower concentration. It is easy. Think about this. There are tons of people outside an stadium, and the stadium is empty. Can these people get inside? Of course. Do they have to fight someone to enter? No. There are plenty of seats for everyone who is outside the stadium, or the theater, or the restaurant. So that's exactly what it is. So here's an example. You have a glass of water, then you put a cube of sugar, or you just pour some sugar in there. This sugar is going to dissolve with the water. You just give a little time. You don't have to do anything. You don't even have to stir the water inside. See, you have water. This glass of water didn't have no sugar. There is no solids within. So you put a cube of sugar or a spoon of sugar, whatever the case might be. And as the little time passes by, this sugar dissolves. Now, here is completely dissolved. There is no energy involved. Nobody did anything. Because there are more liquids right here than solids. So solids dissolves within liquids. And there is a higher concentration outside versus lower concentration inside. There was no sugar here. If I already have sugar and you keep on pouring sugar, then it's going to be difficult to dissolve. But no, it was water. You just put a cube of sugar, just following the images right here, and the sugar is going to dissolve by itself. No energy is needed. When this dissolves within the water, there is no energy, there is no any extra force that happens there to dissolve this sugar. That's called diffusion. So here it says the membrane is permeable to both water and solutes. During diffusion, water and solutes mean solids. But guess what? These solids have been dissolved. So now you cannot separate the sugar from the water. So it's going to be able to pass to a membrane. So this is how sugar is going to pass through the cell membrane. Passing the cube of sugar is going to be very hard. Passing one little grain of sugar is going to be impossible either. So it's not going to happen. So we need to use different techniques to make these liquids. Now liquids can pass through these small pores of the cell membrane. No energy is going to be needed, but it's difficult to pass the solids. So that's called diffusion. Substances from a higher concentration moves into a lower concentration to the cell membrane without using of energy. That's called diffusion. Any questions about diffusion? Remember, diffusion is just a passive transport through the cell membrane. Osmosis. Now, let's see how osmosis plays out. Movement of water across a selective permeable membrane from a region of high water concentration to a region of lower water concentration. So we put a membrane right here in between a glass. We have solids here, solids there. So the ones that are more concentrated is going to move to where there is less concentration. So from here is going to move here. So now they can kind of level up. No energy is needed. These substances is just going to pass from one side to the next. Remember, using a permeable membrane. So permeable means these little pores that allow certain substances to pass through this filter or membrane. That is called osmosis. Now again, these terms usually are not asked, but it's part of the process of transport in and out the cell. It's just for you to know that there are two types of transport, active and passive. So the most important thing about here is active transport does not require energy to do its process. Active, passive, no energy. Active transport needs energy. That's it. Filtration. Now, as the word implies, we are going to filtrate. What is it that we're going to filtrate? We are going to separate solids from liquids. That is it. No energy is required. We just have a filter, pour some water with some solids, only water is going to pass through this filter. Think about the filter of the coffee maker. You put the coffee grains, you have a filter, and then you pour some water in the coffee machine, and then start passing through the coffee, start passing through the filter. The grains stays within the filter, only the water passes through. That's how it works. So that's called filtration. There is always passive, means that substances move from a higher concentration to a lower concentration. Remember, from a higher concentration to a lower concentration. From all these people outside the theater or the stadium and the theater are empty. These people can go in. No effort. Nobody's going to fight them and says, no, you cannot come in. Nobody can stop you. Okay. There's no space. No sitting. You just pass. No energy needed. Remember, passive, no energy. That's basically what it is. Now, active, on the other hand, is the opposite. It's the opposite. Now we need energy. Active transport. Now, substances from a lower concentration moves to a higher concentration. Things change right here. So let's give the example of the stadium. The stadium is full. There are some people outside that they want to come in. They're going to be asked, no, sorry, you cannot come in. The stadium is full. The theater is full. The restaurant is full. You cannot come in, but you wanted to go in. Then you have to use energy because you're going to be pushing people. You're going to be insulting people. You're going to be walking through. So basically, that's different. That's what active transport requires energy. And this energy that we use inside our body is called ATP energy. No worries about the samples. We just need to pass something through this membrane. And because it is very difficult to pass through this membrane because there are many right here inside versus very little inside. So in order for these particles, whatever the case may be, molecules, ions, atoms, needs to pass through this tiny channel, it's going to be having trouble, has to use energy to pass. Otherwise, it's not going to be able to pass to this area. Remember, these substances moves from a lower concentration to a higher concentration. For that reason, they need more effort. They need energy to pass. Just know the definition, just have an idea which of these type of cell transports needs energy, which ones do not. Active transport needs energy. Active, if you are active, you are using energy. If you are passive, that means you're not using energy. You're sleeping, you're chilling at home, just relaxing on the couch. You're not doing any much. So those are the things that I want you to remember for active and passive transport. It's just for you to have an idea how substances enter the cell and how other substances leave the cell through these type of processes, active or passive transport. But remember, the cell is a living organism, so it needs all these nutrients. These are the types of active transport. Endocytosis. Now remember medical terminology. See, here we're going to have it. Osis is the suffix, cyte is the cell or root, endo is a prefix. Within, inside. So this is a condition inside the cell. So anything that enters the cell goes to these processes. So now we are talking about how movement of substances from the outside to the inside of the cell. That is basically what it is. And these particles, these substances that wants to enter the cell, they are large. And because they are large, they cannot just enter to the pores. They don't fit. So how do we are going to pass these substances to this using these processes? Well, we have two types of endocytosis. So we have two ways of entering things, substances inside the cell. One is called pinocytosis, And another one is called phagocytosis. So you need to know the terms for this. It is written right here in red. Whenever you hear the word pinocytosis, this is the process of passing fluids, liquids through the cell membrane. It's called pinocytosis. Cell drinking, pinocytosis. How do cells drink liquids? Through the process of pinocytosis. And it is an active transport, meaning they need energy in order for them to pass. Phagocytosis. If you drink, you need to eat. So cell eating, how the cell gets the nutrients, but we are talking about the solids. See, solids, liquids. So how the cell drinks is called cell drinking. We're talking about water. How the cell eats? Well, phagocytosis. Remember, phago means to swallow. Remember, a condition or a process of the cell, how the cell gets things inside, how they to swallow. So these processes happen. See, this is a cell right here. It is completely closed. These particles cannot pass through the cell membrane. So what the cell membrane does is kind of makes a little indentation. They kind of then makes a little vesicle. Vesicle is like they do an indentation and start growing and growing, and substances start passing. See, going until they enclose it completely and pass the substance inside. They swallow it. They engulf this. So that's how they do it, because it cannot pass it through the pores, because the pores are very small. So what they do is they use the cell membrane to engulf, kind to wrap around the particles, whether it's water or whether it is solids. And then they enter it. That's how it works. So just for you to know, just think about that active transport has two ways of entering nutrients, solids, and liquids into the cell. And of course, they remove things the same fashion. Cell drinking, or when the cell membrane drinks through a process called pinocytosis. When the cell eats, is called phagocytosis. So those are the terms that I want you to remember. What is phagocytosis? What is pinocytosis? Just in case you get it in your exam. Sometimes these questions comes in exams. Cell drinking, pinocytosis, cell eating, phagocytosis. Period. They're not gonna ask you, oh, is this an active transport? If this is no. They're just gonna say drinking, cell drinking. When the cell drinks, what is the name of that process? Pinocytosis. When the cell eats, what's the name of the process? Phagocytosis. That's it. Any questions? Let's go to the second process of active transport, exocytosis. Remember, these processes happens both ways. Things entering and things leaving. So exo means to exit, to leave. how substances leave the cell, how these particles exit the cells. So that's basically what it is. Same process. They use energy, and it's called exocytosis. So once again, endocytosis, endo, you see how important it is to know medical terms, because we know that endo is within, how things enter inside the cell. Exo, how substances leave, get out of the cell. You don't need to know anything else. They're not going to give you samples. I'm not going to talk about here neurotransmitters and how neurotransmitters enters, leaves. No. During another chapter, we might touch bases during the nervous system, but other than that, no, there is no need. For now, just know the terms. Exo, how the substances leaves the cell through the cell membrane, needs energy. Endo, how substances enters the cell, needs energy. Anything less irrelevant right now. Let's talk about this term that is very, very important. Metabolism. You heard about the word metabolism. I know for a fact you have heard, but this is cellular metabolism. Metabolism is a chemical reaction that happens inside the cells. Pay attention to this because this is a very, very important statement. So if you have a question on your exam, they're going to ask you, what is the term used for the chemical reactions inside the cell? Metabolism. All these chemical reactions that happens inside the cells is called metabolism. Well, what is exactly metabolism? Well, let's describe these two types of metabolic actions or reactions. Anabolism and catabolism. I like to start with catabolism first. Why? Because it's a lot easier. Remember, we talk about transport that is passive, no energy, active, needs energy. Well, here is the same. One term is the opposite of the other reaction. So one reaction is the opposite of the other reaction. So let's start with catabolism. Well, what is catabolism? Catabolism is when you have a large structure and you break it down in little pieces. Think about it. If I have a large structure, cannot enter the cell membrane. So what do I need to do? Cut it in pieces so it can pass through. Think about this. You buy a piece of furniture. It is too large. Let's say you buy a bed. You buy a dinner table. When you buy this furniture, they come unassembled in pieces. Why? First of all, sometimes you cannot put it inside your vehicle, maybe a truck or something like, I don't know. Then let's say that's not a problem. You come to your building or your home. How are you going to pass a table that is already assembled? How are you going to pass through the door a bed? Not only it is difficult to maneuver, to manipulate, to enter it. So that is the same situation here with the cell membrane. Has these little pores, but these particles are so big that we need to break it down in little pieces so they can pass one by one in a chain format. Like a link. One link passes, then another, and then when it enters the cell, all the links got together again. So catabolism is the breakdown of large substances to make it smaller. Well, to do this, we need energy. The opposite is also true. Anabolism. What is anabolism? We take a small pieces and we put it together. We build a large one. See, catabolism breaks down a piece in small pieces. So now these pieces enters through the cell membrane. This is the cell membrane. Now they can enter, but as soon as they enter, they're gonna form a large piece because that large piece couldn't pass. See, very smart, isn't it? Our body is the smartest machine that you can find. So this is how it's done. Large particles cannot pass. During metabolism, it breaks down in little pieces, and then when they are inside, they get together again. That is catabolism, to break down a large piece into small ones. Anabolism is to take small pieces and make a large one. That's how the processes work inside the cell. Any questions about metabolism? Remember, metabolism is very common. Sometimes they ask about catabolism and anabolism. So put a little mark right there so you can review this for your exam. So metabolism, all these chemical reactions inside the cell is called metabolism. When a particle is broken down in small pieces, it's called catabolism. When these pieces, small pieces, are grouped together, are put together, now this is called anabolism. Any questions? So metabolism, please do not forget this. Chemical reactions inside the cell is called metabolism. Where are the chemical reactions occurs? Inside the cell. What are the chemical reactions are called? Metabolism. Where is metabolism occurs? Inside the cell. Remember that they can ask you in different ways. They can word this differently. Where the chemical reactions occurs? Inside the cell. The chemical reactions are called metabolism. So you need to know the ins and outs of these terms. You know what is metabolism? A chemical reaction. It's the same. Chemical reaction, metabolism. And where is this occurring? Inside the cell. Any questions? Well, let's talk about another term. This is 100% questions during exams. So homeostasis. Please do not mix this term with another term, hemostasis. Phlebotomy, during phlebotomy, probably you covered hemostasis. Hemostasis is the clotting factors when the blood clots. This is homeostasis. They sounds and looks alike. So homeo, think about home. This is a internal balance. This is the internal balance. Remember, I always been saying that in order for our body to function, needs to maintain an internal balance, a stable internal environment. But I don't use these words. It's internal balance. Everything in our body has to be balanced. Well, your bank account needs to be balanced. If you are spending more than you're earning, that's not balanced at all. And it's getting you in trouble. Well, if you have too much cholesterol, not balanced. If you're getting too much sugar, not balanced. If you don't have enough sodium, potassium, magnesium, chloride, whatever our body needs to function properly, not balanced. So we have to have a balanced system that is homeostasis. So again, there are two types of mechanisms that is going to regulate this balance. When something is needed that you don't have enough, it's going to be a process. It's going to be a mechanism to bring whatever you need. And there is another mechanism that is going to get rid of if you don't need it. That's how we balance. So homeostasis, 100% question on your test. You need to know. Said, what is the stable internal environment of your body called homeostasis? But remember, we use a different term. So when you balance, internal balance in your body, or internal substance balance in your body, what is the name of the internal balance? Homeostasis. Homeostasis. In order for this homeostasis to function properly, we need two actions right there. Remember, two mechanisms. I'm going to talk about these mechanisms. Negative feedback. So think about this. If we have something that goes down, it's going to bring it back. If we have something that goes too much, it's going to put it back. So that's basically what it is. I'm going to give you an example. So you are running. What happened to your blood pressure when you run? Goes up. What happened to respiration rate? Goes up. What happened to your pulse? Goes up. But it doesn't stay up. Why? Because when you stop and you rest, negative feedback brings all these vital signs to normal. That is called negative feedback. This is one of the most common mechanisms of homeostasis. Remember, homeostasis means to keep your body balanced. And if something goes up, this negative feedback brings things to normal. If it goes low, brings things to normal. If you eat something that is too salty, well, how your body is going to regain? Because it makes you thirsty. So you have to drink water so you can mix, you can dilute this excess of salt. The same with something that is sweet. You eat something or drink something that is very sweet, your body immediately reacts to it and give you this sensation that you want to drink liquids because it's too sweet, because it's too salty. If it is too hot, you start sweating. This word, you're losing liquids, fluids. What is your body, your brain is going to tell you to do? To drink some fluids so you can hydrate yourself because you're losing fluids. That is negative feedback. So you are hungry. Your brain is telling you You are hungry. You need to eat something. So then immediately you look for something because your body is asking you for it. It is balancing everything that happens inside our body, the hormones. When females are going to have the menstrual period, then immediately your brain sends information to these glands that produces these hormones to be released. So you can have the menstrual period if you didn't become pregnant, and vice versa. If you become pregnant, the brain is going to send some signals to these glands not to release these hormones so you can keep your wall, your placenta inside your uterus because you have become, to have an implantation of an egg. So it happens with everything. If you have a lot of sugar, oh, well, water by itself is not going to fix it. So then the brain is going to send the signal to the pancreas. The pancreas contains these cells, these hormones that are called insulin. And it's going to tell insulin, hey, you need to multiply your cells and go and attack all these sugars. Remove the sugars that we don't need. Only leave the sugars that we need. That's how it is. The problem is that when we eat too much, too often, we're not going to have enough insulin to keep up with the excess of glucose. So glucose is going to be accumulated inside your blood, and now you develop diabetes, or now you develop cholesterol because you're eating too much fatty foods in your diet, or too much salt. Now you have an increase of blood pressure due to excess of sodium, or you're losing things. So your body tries to bring back to normal. So if my blood pressure goes up and it's not a medical condition, it's not a damage to my structures, then the body tries to correct themselves. Otherwise, we have to correct the structure that is not doing their function. Think about your car. If the alternator breaks down, well, you have to replace it. The car by itself is not going to start your engines if something goes wrong. So it needs to be fixed. But if it is the gas that ran out, you just put gas, that's it. So negative feedback is trying to reverse an action that is called negative feedback. Reversing an action, something that went up is going to bring it back. Something that went down is going to bring it up to normal, to balance. That's basically what it is. Body temperature is one of the samples. Remember, I've been telling you vital signs, glucose levels, your blood pressure, your pulse, your respiration rate went up because you were doing exercises or because you got very upset. Emotional things affects everything. But it does imply that you have a medical condition. No, I got upset because somebody just pissed me off. Or I received bad news. I was fired from my work. I'm very upset. Or something else. Or got a fight with someone. But then as soon as I calm down, my blood pressure and everything is going to go down because negative feedback is doing its work. You're not going to stay upset forever. You're not going to keep crying forever, laughing forever. So these things changes accordingly. Once again, negative feedback works only when the process have changed, but not due to a medical condition. If it is a medical condition, a damage to some of the organs, we have to repair them because they are not working, they are not functioning. That's called negative feedback. reversing an action, putting this action back again to normal, that is called negative feedback. Any questions? So if we have negative feedback, we have to have positive feedback, right? So that's basically what it is. We have here positive feedback. So it is the opposite. Positive feedback is not common. Remember, negative feedback is the most common because it's the one that we need the most. If it's something changed, my electrolytes went up, I need to bring it back. If they went down, I need to bring it to normal. It's reversing an action. Something goes up. Oh, they have to stop it, put it back. Well, positive feedback is not like that. Positive feedback is the contrary. It continues until something happens, until that reaction or process ends. So think about this. You're starting this program, right? This is positive feedback. Why? You started today and you move through all these modules, and then you have your final module, your internship, done. You finish your program. That's it. That's positive feedback. You don't need to go back and start taking the courses again because you're going to become a medical assistant ×2 or ×3. It doesn't work that way. I start my career, I finish on this day, I'm a medical assistant now. I'm a doctor, I'm a nurse, I finish. That is positive feedback. Something that continues until the reaction ends. So let's give you an example. Pregnancy. So pregnancy has beginning, has an end. It's not that you become pregnant and it says, you know what? Negative feedback is going to bring me when I was not pregnant. That doesn't work, right? So it's going to continue the pregnancy. Let's say that everything goes right. Continue the pregnancy until the due date. That's it. You deliver the baby, positive feedback ends. So it's not something that is going to reverse an action like negative feedback. This is going to continue the reaction or the process until the process is ended. That's it. As soon as it ends, done. So increase, moves forward. When the process ends, that's it. That is called positive feedback. It is short-lived. Now, what is short-lived? Because it has an end, it has a beginning, and it has an end. It's not like go back and forth. Oh, I don't want to become pregnant. I'm not pregnant. So no, that doesn't work that way. Even though if you terminate your pregnancy, well, you finish right there. That's it. So that's how it works. Another example is blood coagulation. See, you have an injury. You cut yourself, you're bleeding somewhere. Well, the blood clot formation begins the process as soon as you get injured. And when the injury is fixed, blood coagulation ends. That's it. It doesn't continue, doesn't reverse. Oh, no. I'm clot. No, I'm going to unclot myself now. Doesn't work that way. So there are certain processes, and you see that there are not many processes like that you do something and you continue. No. So basically, the most common of these homeostatic mechanisms is negative feedback. It reverses an action, try to put it back to normal. It balances it out. positive feedback, it doesn't. It continue with the reaction until the process is completed. That's it. Any questions about negative or positive feedback? So just for you to know it, it's important that you know that these mechanisms exist, and that's what help us out to have all these reactions in our body, inside our body, whether through the negative feedback or the positive feedback. So that's how it functions. Okay, so we're done with this part of the cell, this part of the functioning of the cell. Now let's talk about the cell cycle. Now we are going to talk about cell division, how the cell goes through these stages to divide, because cells divides. One cell divides into cells. Those two cells, each one divides themselves into cells. So now I have 4 cells. Those 4 cells divides 8 cells. Then 8 divides and then become 16, and so on and so forth. In order for this to happen, cells needs to go to a process or series of changes. So let's talk about these stages of the cell cycle, meaning the cell when it's ready to be divided. Think about a female. Oh my God, don't blame me saying that I always throw it to the females, but the females are good samples for a lot of stuff. So think about the females, because the females become pregnant, right? Males do not. So I cannot give a good sample using a male for this cell cycle. No, it's not. So think about the menstrual period, think about pregnancy, think about all those stuff. So females starts certain age having the menstrual period. Then they are ready to become pregnant, right? Well, the cells happen the same. If you have not had the menstrual period yet, you are immature. You cannot immature biologically. Because we have 40s, 60s, we have 80s, immature people, right? We're not talking about that. Mature by age. So that's basically what it is. You have to reach certain stage, certain age in order for you to be able to become pregnant. But something had to happen. So the cell is the same. So the cell goes through the following stages: interphase, then mitosis, and then cytokinesis. So we're going to talk about what is interphase, what is mitosis, and what is cytokinesis. All this is very important for you to understand how the cells reach a certain point when it's ready to become pregnant, so to speak. When it's ready to divide, it's going to be divided in 2 equal cells. One cell divides in 2. Because we have millions of cells, can you imagine each cell dividing in 2 when they reach the majority of age? So that's basically the cell cycle. So we're going to talk about what is interphase, what is this stage, what happened to the cell, what is mitosis, what happened during mitosis, What is cytokinesis? What happened during cytokinesis, these stages? Remember, it's like being an infant, being an adolescent, being an adult, being an elderly person. Oh, those are stages. So these stages, let's say, we're going to put it within the cell. Interface. So just to make it very, very simple for you, interface is the stage when the cell is ready, is mature enough to become pregnant. That's it. So this cell is ready to be divided. That is interface. It's not immature, it's not a baby cell, it's not an adolescent cell, it is an adult cell. It reaches the adulthood. Now it's ready to take in some duties, right? Ready to go work, ready to do a lot of stuff. Let's put it away. It says right here that the interface is a very active period in the cell cycle. Is when the cell grows. Now the cell is mature enough. Cell maintains normal functions. It's already formed, it's mature. It has all the components inside. It has all the structures to be able to divide. So it is a complete cell. That's it. All the organelles, all the cytoplasma, all these organelles are functioning correctly. The ribosomes, the mitochondria, the lysosomes, the centrioles, a bunch of structures that are inside. They are already mature. They are functioning normally. So it is time for this cell to divide. See? Cell division. We have everything right here to prepare cytokinesis or cell division. So that's basically what it is. So I'm telling you in very layman terms, give you examples so you understand what interface is. If I read all this stuff that is right there, listen, I wouldn't even understand it myself if I wasn't familiar with this. But this is how it works. The cell during interface is mature enough, has all its structures already developed, is ready to have babies, is ready to be divided. That's it. So now we're going to move to mitosis because this cell is already ready to be divided. So we move to mitosis, which is cell division. But the cell division has stages. How is that? That is like pregnancy. Third trimester, second trimester, first trimester, second trimester, third trimester. The female is ready to deliver the baby. So it goes to certain stages. So we're going to move to mitosis or cell division. Questions for your exam. The process of cell division is called mitosis. Mitosis. It is written right here. Mitosis, division of the cell, but no worry about the nucleus, just cell division. Cell division, mitosis. That's it. That's all you need. It's very important for you to understand this. Now, to go through this process, remember cell division, it is mitosis. This says right here, fast phases of cell division. Well, we're going to have something that is called prophase, Prophase is the first stage of cell division. What happened here? During prophase, think about this is a cell. This is the nucleus. Inside, we have all these organelles. Remember, we have all these organelles. Now, this cell needs to be divided, but first, which part of the cell is the most important one? Where do we find DNA? Where do the genetic material, the RNA, the genetic material, the chromosomes here within the nucleus? So what we do is, what the cell goes through is this nucleus inside the cell, which is the brain of the cell, is going to divide. But how is that going to happen? Here it has a membrane, the nuclear membrane. Well, during the prophase, this is what's happening. These membranes start dissolving, disappearing. Why? Because it has to release the genetic material that is here. The chromosomes needs to be released because it's the brain. The brain needs to kind of be released. So the membrane starts disappearing. Now the chromosomes are free. And those chromosomes are the ones that are going to be divided. They are going to be divided to form two equal cells. So two equal daughter cells, if you will. So that will be the prophase. So there are other things that happens during that process, but we're not going to go over every single detail that goes during the prophase. No, we're just going to say that this nucleus membrane is disappearing, releasing whatever is inside, which is the genetic material, the chromosomes. That will be the prophase. Now we are going to have the second one, the metaphase. Think about pro. Pro is like pre, before. Before the cell divides, we're going to remove the nuclear membrane so we can release the chromosomes, the genetic material, which are the brain. We need to divide the brain in two, so we can have two equal daughter cells. Now we have the metaphase. Meta, think about meta as middle. Think about that. So what happened to metaphase? During metaphase, what we do here is that all these chromosomes that are inside start getting divided. There are some structures that are called the spindles. Not gonna go through that, but they start pulling chromosomes, one to the North Pole, one to the South Pole, the other one to the North Pole. So they start pulling to this side, pulling to this side. All these chromosomes lining up in the middle. That's what is called metaphase. The chromosomes are gonna line up in the middle because something inside the cell is pushing the chromosomes to the sides. So pushing, and this cell is gonna become elongated. Why? Because all these chromosomes are lining up right here in the middle or right here in the middle, and these spindles are pulling them. They are in the middle. Now they start pulling them one to this side, the other one to this side. So we can break this cell in two. That's what is called metaphase because the chromosomes lining up in the middle. That is metaphase. Now we have something that is called anaphase. Now, during the anaphase, these chromosomes are already on one side. They are already in one side. They already pull to each, that is anaphase. During telophase is the last of the processes or phases of mitosis. During telophase, now we have here all the chromosomes from one cell and all the chromosomes for the other one, and we have this. So now the cell looks like this. Still attached, but here we have one cell, here we have, but still attached here by the cell membrane and the cytoplasm. That is telophase, which lead us to the cytokinesis later on, the next process. So remember, it starts with a process. Let's look at the pictures, not pictures, images, I might say, where we have all these processes that I try to scramble here because I'm not a good drawer. So anyways, I try to do my best, but it doesn't match. Okay, here. So this is mitosis or cell division. As you can see here, mitosis, cell division. That's what I want you to know. They're not going to ask you about these phases. So this is the inner phase. So the inner phase, the nucleus is complete. The cell is ready, is mature. Then we have the prophase. During the prophase, we have this membrane dissolving. So we can release all these chromosomes. And you see these lines right here? These are the spindles. And these are the centrioles. But we're not going to talk about the whole process because that's not needed. So you're going to get confused. So it's just basics. Now all these chromosomes are released because the membrane was dissolved. So then we're going to have the metaphase. What happened during the metaphase? All the chromosomes are lining up in the middle. That's what is called metaphase. Then it comes the anaphase. What happened to the anaphase? Each of these spindles start pulling the chromosome from the center through the sides, through each side. One goes to the left, the other ones to the right. See? They start pulling them, pulling them, pulling them, separating them. Each one of these poles start doing it. Those are called the centrioles. Then during the telophase, we have already moved all the chromosomes for this cell and all the chromosomes for these two cells. Now we have here two daughter cells, but these cells are still attached. They look like siameses. They are attached by the belly. Well, we don't want that. We want to have individual cells. Well, then it's going to come the process of cytokinesis, which is the breakdown of this cell membrane. And now we have two independent, complete daughter cells. Daughter because there's one that divides in two. So that's basically what it is. That is the process of mitosis. So I'm trying to make it very easy because this is not simple. So I'm not going to give you all these in and outs, all these terms and processes and every single little step of the process, because that's not the purpose of you for, that's not my purpose for you to understand this. So I want to make it easier. So we have a cell. This is a girl that already have the menstrual period, is ready. So we have interface. Now the baby start forming inside, let's say, the placenta, the implantation, and all the stuff, then start growing, and so on and so forth. Now it's time for the delivery. So goes through these stages. Of course, has a little differences because we're talking about the division of the cell, but it is similar. The steps that it goes, not that they are similar in action, but it's just there have some stages. That's basically what I'm talking about. Here it tells us, see, the stages, the prophase, the metaphase, the anaphase, and the telophase, for you to review it, but it has a little more details, but that's not my intention with, with this class for you to understand how mitosis happens. So it just goes simple. Little, just one keyword that is gonna tell me what happened during the prophase, during the metaphase, anaphase, and telophase. That's it. But remember, for you, you need to know what is mitosis, cell division. Now, the last stage. Remember, the last stage is the cytoplasmatic division or cytoplasmic division. So now that we have the cell, remember in this picture right here, that is still attached by the belly, if you will. So now we need to separate it. Well, we're going to separate them through a process called cytokinesis. What is cyto? Cyto is the liquid portion inside the cell, but it's also part of this membrane that we need to separate. So we need to break down. So here we have the cytokinesis, the two cells, but still attached right here in the middle. So we need to cut this, remove this, and then we're going to get this. So we're going to get two of these cells, two complete cells with their own nucleus, with their own chromosomes, their own genetic material. Newly formed cell will have identical DNA, may have a slightly difference in size, number of organelles. Who cares about that? It's identical. So whatever this cell has, the other one has, because it has to have all the organelles. Slightly different. Well, it might have a little difference in between sizes, things like that, but it's two cells, two functioning cells. And now these cells, individual cells, are going to follow the same process of cell division. So you have more cells, more cells. Because remember, these cells of our body, they don't live forever. It has to be replaced. For the new ones, for the new ones, for the new ones, we don't live forever. So we have our offsprings, and then we die, then they have offsprings, then they die, and their offspring has others and others and others, and that's how the cells are doing. So that's basically what it is. So don't worry about details, worry about just one step for each of these processes. What happened during this process? What happened during this process? That's how I remembered all this. Do you think that I'm reviewing this all the time, that I'm reading this all the time? No. When I learn it the right way with all its complexities. Now, for this class has to be very, very basic, because it's a lot of stuff. Okay. Any questions? We're done with this chapter. So let's take a break and then we start with the next chapter. Shall we? Because it's 6:45. So I don't want to start a chapter and then cut it like at the beginning and then continue later on. I don't want you to lose kind of continuity, sense of whatever we're doing. So let's take a break. We come back at 7:20. Is that okay? Yes, no, maybe.
Okay.
Okay, so we come back
That's
at
fine with me.
once again 7:20, and then we're gonna continue with another chapter. Enjoy it. You break. Okay.
Okay.
Okay, you're welcome. Okay. So we are back. How you guys enjoy your break?
Yeah, teacher.
Okay. Garcia, Xiomara.
Yuan Yao.
Oh no, there's Garcia. No, I know. There is two new students that joined the class today. Garcia, Xiomara, and Darlene Ovales. So we're gonna give them a welcome to our class. I don't know if they are already there. They joined the class already, but I don't know if they came back already from break. Miss Garcia.
I'm here.
Oh, how you doing? Welcome
Hi.
to this program. This is Professor Hoyer. Um, okay, so have you taken courses related to
Y-
medical before, or it is your
Yes.
first time?
I did medical billing
Okay, so you have an idea
with
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 diagnosis and
with
things like that.
yes, the same school. So I know more or less a little bit, but whatever I don't know, I take notes.
No, that's fine. I
Yes.
already sent you the presentations. You don't have to take notes. Take notes of things that are not written within the notes. Check your emails. I send it to your personal email. I just received a message from the school. So, um, whenever you have sometimes now or later on, you can check your notes. Everything that I'm covering right here, you have it on your email. Okay.
Yes. What I was gonna do was when I get to work tomorrow, I was gonna print out the
I don't know if it is recommended. There's a lot of papers and kinds of quite expensive. I don't know. Maybe if you do it at work, if you have a photocopier over there, maybe you can get away with. Other
Yeah, I
than
could
that,
get away because I did it with my
okay, all
medical
right,
billing. It's fine.
not a problem. Okay, nice meeting you.
You too.
I also have Darlene Ovales. Darlene.
Yes,
Oh, hi, how you doing? Are you in the field of medical or it is your first program related to medical?
this is my first program related to medical.
Okay, so never took classes or anatomy or any other courses related.
I've taken like living environment things like that. Some other things are like a refresh and things like that. So yeah, some things are new, some things are not.
Okay, so I'm trying to go very, easy, very basic with these classes. So, just as the way that I told Xiomara, I email you all these lectures for this module. You have it on your personal email, okay? So whenever you have some
Yes.
time, check them out and follow the lectures so you don't have to take every single note. Okay.
Yes, the email.
There is also a video recording for each lecture. So you can go back to these lectures whenever you have some time as well.
All right. Yeah, I've
Okay.
seen the email already.
All right, perfect. So welcome to the class again. And whenever you guys have any questions, any issues, just don't hesitate and email me, okay? The same email that I send you the lectures, you can email me back. And you can contact me if you need anything or you just need assistance with anything related to the program, okay?
All right. Thank you.
Okay, you're welcome. All right, guys, let's continue then with the next chapter. This is the skeletal system. See, when we talk about anatomy and physiology, is kind of, you know, self-explanatory in a way because the system tell us exactly what we're going to be talking about. If we said the skeletal system, that means that we're talking about bones, right? So that's basically what it is. We're going to talk about most of the bones of our body, uh, bones formation. We're going to talk about the cells that makes up the bones, the function of the bones particularly, And we're going to mention some of the different divisions of the skeletal system. So that's basically what it is. I will tell you as we move through the chapter what is important for you to know for exam purposes. Anything else is kind of basic for the job that you're going to be doing. But most of this stuff, you probably might not need it, but you need to understand this. So when you're doing a procedure, when you're doing an exam, when you're assisting the doctor, you know exactly what's going on and what part of the systems of the body the medical doctor is treating the patients that you're assisting with. So that's basically what it is. And not only for that, you can understand when the doctor diagnoses you with something or talk about the system, the structures, you're gonna have an idea of what's going on. It's a lot better when you know something than when you actually ignore every single detail. Okay, so bones. Bones are organs. The skin is an organ. The heart is an organ. The eyes are organs. So the bones are organs. So they are made of special cells, the bone cells. Later on, we're going to mention what's the name of them. So there are other structures that works alongside the bones to do their functions, if you will. So we have bones, tissues, cartilage, connective tissue, blood, and the nervous tissue. So in other words, the bones are living organisms. The bones looks like, hey, it is bone, has no life. No, it does have life because it's a living tissue made of living cells, has cartilage, has some connective tissue because it's a connective tissue because you put bone next to another bone to another bone to form the skeleton. So it is a connective tissue. It connects because it's a living structure, a living organ. It has blood vessels within. It has nerves because whenever we have pain, it's because the nerves have been disrupted within the bones. So every single living structure has to have blood supply because it needs to have nutrients, hormones, all these electrolytes, all these chemicals that are going to be necessary for this growth to keep functioning normally. So that's basically what it is. They have different functions. One of the major functions of the bones, as is depicted in this slide, is support and protection. So they support and protect soft tissue. It protects internal organs. Think about this. We have the skull. The skull is a bony structure. It protects the brain. The hips, the hip bones. It protects all these internal organs from the reproductive and the urinary system. The rib cage, all these chest bones, they protect the lungs, the heart, and other blood vessels and other structures within. So it's very important for us to have these kind of structures that are going to protect this soft tissue that otherwise it will get damaged. Can you imagine somebody punches on the chest and we didn't have the ribs? Then it's going to go directly to the lungs or to the heart. It's going to damage them a lot easier. A fall, just walking, that will be difficult to walk without bones. Can you imagine with just tissue? So that wouldn't be a good idea, right? The bones also serves as a points of attachment for the muscles. Remember, the muscles are attached to the bones. Can you imagine the bones but themselves, or the muscles but themselves? Well, they have functions, but some of the functions will not be met. For instance, to stand erect. We can be standing erect because the skeleton forms this frame, this structure that is going to be attached to these muscles so they can give us some type of shape. Another thing that is very important from the bones, all the cells from the blood are produced here. Red blood cells, white blood cells, platelets. They will be produced within the long bones. We're going to see where exactly within the bones these red blood cells are going to be produced. So basically, very important functions. So we need to kind of be very basic with this system because it has lots of terminology that sometimes is difficult to grasp at first. But little by little, we're gonna get familiar with this. Another function that the bones has, stores minerals. They store minerals, calcium, phosphorus. So that's basically what it is. Remember, if the bones becomes weak because they don't have enough calcium, they break easily, they damage. So once again, bones stores minerals. They do not produce this. The bones do not produce calcium. It stores the calcium. So whenever it's needed for the bones and for other functions within the body, the bones are going to release this calcium. So that's basically what it is. We have lots of functions, lots of things to discuss about the bones. So let's talk about the shape and the size of the bones. The bones of the skeletal system vary greatly in size and shape. Yes, not all the bones of our body are the same. They are the same length or the same shape. They have different size and different shape. Now, they develop in the same fashion. So their structures, their functions are the same because they are made of the same type of cells. So regardless whether it's a small bone, flat bone, a long bone, a short bone, still they're gonna be made of the same cells, have the same functions because it's the same system. So that's basically what it is. Now the cells that makes up the muscles are gonna be different. We're not talking about them. We're talking about the bone cells. The bone as a independent organ. So that's basically what it is. So let's see bone shapes. There are long bones. There are short bones, flat bones, irregular bones. So let's mention some of these long bones. The humerus. The humerus is this long bone that makes up the upper arm and the lower arm, the upper leg, the lower leg. All these are called long bones. Short bones. For example, we have the bones of the fingers, the wrist, the toes. So the foot fingers has a bunch of little tiny bones. It's just that they are covered by skin and muscle, so we don't see them. But yes, we have a bunch of little bones with these structures. Flat bones, very easy. The shoulder blades or the scapula, the skull. It looks like it's rounded, but it's flat. It is flat. The ribs, they're flat. The collarbone, they're flat. The hip bones, they're flat. So again, we have plenty of bones that have different shapes. Irregular bones. Irregular bones are those bones that are not long, they are not short, they are not flat. Those are bones that is difficult to describe, meaning they have so many protuberances, so many points to the right, to the left, up, down, that is difficult to describe and give them a particular name. So we call them irregular. These irregular bones, the most common of them are the vertebrates, the bones that makes up the spinal column or the spinal bones. They are irregular because we don't have a definite shape for these structures, these bones. So now we know that the bones are organs. They are living organs. Just because they are solid, just because they are not soft tissue, does not imply that they are dead. No, they are not. Every single structure in our body is a living structure. The hair, the nails die. It is just made of certain structures that are very hard. They might not contain blood vessels. They might not contain nerves within, like the nails and the hair, but they survive of structures like the skull or the bed of the fingers or the toes. So once again, we need to be alive so they can function. But we're talking about the bones right now. Let's talk about the parts of a long bone. Why do we choose long bones? Because the long bones are the ones that has most of the structures, because they are large enough to be kind of evaluated. So if we kind of cut one of these bones diagonally or vertically or horizontally, anyway, we're going to find certain structures within the bone. So let's talk about the parts of a long bone. Remember, we're going to start with the structures that we see from the outside. So these structures, like the heads of the bones, the head of the bones, the two ends, the two extremes of the bones are called epiphyses. Epiphyses. The center or the body of the bone, we remove the heads, everything else, this long prolongation of the bone is called diaphysis. So long bones are made of three parts. The ends, the heads, or the stream of these long bones are called epiphyses. So each long bone has two epiphyses because it has two ends, two heads, two extremes. And the part in between the two epiphyses is called diaphysis. So do not worry about the other parts for this moment. We're going to talk about them, but we are talking about the parts of a long bone. Now, when we start talking about the layers or the walls of the long bones, that's a different issue. Then we can talk about periosteum, compact bone, and endosteum. But for now, we're going to focus on epiphysis, diaphysis. Very simple. So once again, I'm gonna try to do this as basic as possible without giving you too much of this jargon terminology, because then this we have to mention it. But I'm going to use layman terms for you to understand that the ends, the streams, the heads of a long bone are called epiphyses. The part in between the two heads is going to be called diaphysis. Remember, these are medical terms. So let's define them. Remember, everything that I'm been telling you is written here. Of course, I add little things here and there for you to comprehend better these lectures. But I use most of the time these layman terms, something that you can understand. So here it is again, the epiphysis or ends or heads or streams of the bones. Diaphysis is the body or the shaft of the long bones. So that's basically what it is. Now, we are going to be a little deeper with this, but we're not going to go to the medullary cavity right now or the hematopoiesis. No, because that's going to be too much. Let's go back here to these long bones. Now, these long bones have three layers or three walls. This one, this very thin layer goes all over the bone. So I'm marking the ones that is right here. So this is the outer layer of the bone. That's called the periosteum. Periosteum. Peri means surrounding, above, outside. Osteum means pertaining to the bone. So this is the layer, the wall on the outside of the bones that surrounds the bone. That's the periosteum. Now let's do the center part. It's going to be in yellow. All this yellow part is going to be the middle layer of the bone. So the middle layer of the bone is right here, is going to be called compact bone. The compact bone is the middle layer, is the thickest part of the bone, is the hardest part of the bone, the compact bone. Next, let's talk about the inner layer. So right here, let me see. Right here we have the inner layer. So the inner layer. This is called the endosteum. Remember, endo, inside, osteum, pertaining to the bone, the inner part of the bone. So it has three walls: the periosteum, the outside, the outer layer, the compact bone, the middle layer, the endosteum, the inner layer. Now you can see right here that there is a, let's change the color. No. Okay, so right here in the middle, there is a space. There is a little hollow space. And you know this because when let's talk about a chicken bone, a chicken leg bone. When we eat the chicken leg bone, and if we cut it and we break it, it has a hollow space. And there is something in there that sometimes is kind of tasty. Why? Because here is where we have the yellow marrow. This is fat. Remember, fat tastes good. So now we move to this part right here. The medullary cavity contains the yellow marrow. This is just fat. This is just fat, cholesterol inside the bones. Every single bone has that. If you happen to have chewed through a bone, whether pork or something else that has a big hollow space and it has some stuff within, that is the yellow marrow. And it tastes good. I've tried, and I'm embarrassed to tell you, most of us have. So now that you maybe don't like it, it's not that I like it, but I have tried it. And it does taste good because it's fat and it's a little salty. So it's delicious. Anyways, so that is the medullary cavity. So inside that bone, the hollow space inside the bone carries the medullary marrow. Remember, this is the yellow marrow or fat. Now, let's go back again to the same picture. This part right here, when we have the compact bond, but you see that there are some little dots right here. Let's put a different color. So, okay, so right here you see some dots, some dots, some dots. Well, this is called spongy tissue. Some parts of the long bones are soft. So when you chew on them or when you try to break them, they're soft. It's like spongy there. And it tastes good. This is like the chicken heads of, the chicken streams of the bones. So it tastes good. And inside looks like brownish. Well, actually, it's not brownish. It's red. Because here is where all these red blood cells, white blood cells, and platelets are produced. So this is the cancellous tissue. But we call it just spongy tissue, or we just call it inside the epiphysis. So this is where red blood cells, white blood cells, and platelets are produced within the epiphysis. So we go back here to the picture. Now we can tell you, see, this is the epiphysis. These are the heads and or streams of the long bones, contains the spongy tissue, and this contains the red bone marrow. Oh, now we understand. Now, red bone marrow is the one that produces all the blood cells. Red blood cells, white blood cells, and platelets. You heard about bone marrow transplant, probably. Well, this is the place when we are going to get these mast cells, these mother cells, and we are going to transplant it to someone else whose mother cells are failing. So we're going to give them new, fresh mothers. And what is it that mothers do? They have babies. So these mother cells from bone marrow, they are the stem cells. So they will be producing other cells. And that process of producing more cells is called hematopoiesis. Be careful with this term because this term is very important. They're going to ask you in the exam, what is hematopoiesis? Oh, hematopoiesis is the production of red blood cells, white blood cells, and platelets. So blood cells production, that's basically what it does. Hematopoiesis. Remember, hemat means blood. Poiesis is the process of producing these blood cells. And where are these blood cells produced? In the long bones, in the epiphysis of the long bones. The process of producing new blood cells is called hematopoiesis. That is what is important here. They're not going to ask you about diaphysis, the medullary cavity. No, they're going to ask you the red bone marrow, because red bone marrow is very important for medicine to treat conditions of the blood. So that's basically what it is. This is going to be repeated as we move but if you wanna kind of highlight it, write it down, this is the part that you need because you need to know how this works. So long bones have three parts: epiphysis, which are the ends or the heads or streams of the bones. The bones have three layers. They're not gonna ask you, but you need to know. The outer layer is called periosteum. The middle layer is called the compact bone, and the inner layer is called endosteum. The inner layer, which is the endosteum, is the covering for the medullary cavity. So this is the one that makes this space. And what do we find in the medullary cavity? The yellow marrow or the yellow bone marrow. What about the red bone marrow? Where do we find it? In the epiphysis. You're not going to say in the compact bone. That's not how it works. Because it's not within the compact bone. It is within the heads, the ends, the extremes of the long bones that are called epiphyses. What is the process of red cell production? Hematopoiesis. That is it. That is what you need to remember for this chapter, for this line. There's lots of things you need to remember for the entire chapter. But I'm walking you through the things that you keep in mind, the things that you have to review when you are about to take your exam. Okay. Any questions? Okay, so here are the layers or walls of the long bones. Periosteum, remember I mentioned it already, outer layer. That's all you need to know. Well, yes, it's the outer layer, so therefore it covers the entire bone, right? Except for the joint, meaning the ends, the diaphysis. The diaphysis is not covered by this bone. It's only or everything about the diaphysis. So that's periosteum. Because the heads of the bones are soft. You don't need this hard coverage in there. Compact bone is the middle layer. Is that right here? Is the hardest part of the bone. I already told you. It's the hardest and is the thickest. It is so hard, this area, so strong, if you will, that they are made of special cells these special cells that makes up the middle layer of the bones is called the osteum. Osteum. Then we have the endosteum, which is the inner layer. See, it lines the medullary cavity. So inside the endosteum, we have the medullary cavity because this is the hollow space in between, inside the bone. And it's made up by the endosteum because the endosteum is the inner layer. After that, we just have this hollow space, which is called the medullary cavity. And there's when we have the yellow marrow. So that's how it works. Periosteum, compact, and endosteum. These are the three layers of a long bone. Okay. So once again, usually these are not common questions for exam, but if we're talking about the structures of any of the organs, we have to mention it. But we're going to mention it then in a very basic way. So you kind of retain some of this information a lot easier. So here is the same bone. Now we can see the structures a little more defined because it has color. It has the whole bone has been cut vertically or horizontally, whatever you want to think of. So here we have the epiphysis. See, this periosteum comes up to here. That's it. Just from here and then it is soft. Here it's not periosteum, it's very soft. And here it has cartilage. Same in this side. Here it has cartilage. It's soft, doesn't have the periosteum. Now you can see here all the porous structure where the red bone marrow is. Red bone marrow is. See, here we have the compact bone. Now let's change the color because otherwise it's gonna be the same. Green, let's put this green, all these compact bond, which is the middle layer right there on both sides. Middle layer and the middle layer right here, see? The middle layer right here. And the inner layer, let's change the color. What more color we're gonna use here? Let's put a blue. Oh, here is the inner layer. Here is the inner layer. The inner layer here and the inner layer here. And now you see this is the hollow space, which is the medullary cavity. And here is when we have the yellow marrow. See, and here is we're gonna have the bone, the red bone marrow right here, or spongy bone. So within the epiphysis, which are the heads, the ends of the long bone, this is where red blood cells production is going to happen, which is called hematopoiesis. Just like that. So I have these two images because it's a lot easier to see some structures inside the bone than otherwise the other picture didn't give us the chance to see. So that's basically how these bone structures are viewed here in this image. So just simple. If they ask about the bone parts, then you say epiphysis, diaphysis, two epiphysis, one diaphysis. But if they said the layers of the bone, of the walls of the bones, then you have to say periosteum, compact bone, and endosteum. Bone, marrow. We have yellow marrow and we have red marrow. The red marrow is within the epiphysis and the yellow marrow is within the diaphysis. See, diaphysis, yellow marrow because it's within the medullary cavity, but it in the diaphysis. And the red bone marrow is within the epiphysis, the spongy bone. So that's basically how these plates are. It's a lot easier to see it this way. Any questions? Okay, moving on. So let's talk about these microscopic structures. In other words, let's talk about these structures that makes up the bones and the cartilage. You need to know these. So write it down somewhere, put a note. We have two major types of tissue, bone and cartilage. So bone and cartilage works together. So cartilage will be located in between the bones. So here is one bone. Here is another bone, right? Well, in between these bones, you have to have cartilage. Why? Because it's softer. And when these bones collide, moves against each other, the bones are not going to be damaged. This is like putting a cushion right here in between, putting a pillow in between. So all these articulations that we have in our bones, they have cartilage. Not only here, but they have it right here at the extremes of these bones. They have a space right here with some fluid, some membranes. So they work side to side. So they need to work together. Remember, if they are not working together, then we're going to develop some type of joint conditions like arthritis. That is the problem. Let's talk about these cells that makes up the bones. The bone cells, let's put it this way, are called osteocytes. Cytes are cells. Osteo are bone cells. That's how it's done. Cartilage cells. Cartilage cells are called chondrocytes. Cytes are cells, just like here. Chondro means cartilage. Cartilage cells. So remember these two terms because you will be asked, what are the name of the cells that makes up the bone skull? What are the name of the cells of the cartilage? Or what are the name of the cells that cartilage is made of? So osteo, remember osteo is bone. Cytes are cells. So that will be bone cells. Chondro, once again, means cartilage. Cytes means cells. So cartilage cells. So put a note right there on your notebook or your laptop, whatever you're using to take notes so you can add little things here. Just put a check mark. Say, this is what I do. When I'm taking my classes, well, when I used to take my classes, the teacher started mentioning something. The teacher didn't tell me that it was going to be a question for the exam. No. But they repeat this over and over and over. I said, question, then exam. I knew that I have to review this. Question, exam, or test. Whatever make you feel good, whatever make you remember this. Other than that, it doesn't work because you're gonna have so many notes and you're not gonna go through every single note when you're gonna take a test. You're gonna go over the points that are crucial, that are more important. But I'm telling you, remember this, remember this. These questions are gonna come out on your test. So basically, that's how it works. So we have these special cells, osteocytes and chondrocytes, that have their own functions because they work alongside within the bones. Okay, so these are the major functions of the bones. We mentioned some of them, but now we're going to be a little more specific. So support, protection, movement. Yes, the bones not only support and support what? Support the muscles, support other bones so we can be able to move. Can you imagine without the skeletal system, without these bones, only muscles? How can we walk? We'll be rolling, not walking. What will be the shape of our body? There's no shape. We will be like a mass right there, like a big mass of tissue, muscles, skin. That wouldn't be nice. So wouldn't be able to move easily. So that's basically what it is. So the bones provide shape for the head, the face, the thorax, the limbs. They are independent structures, have their own shape. If you say head, immediately you know what they're talking about. Limbs means arms and legs, the extremities. Thorax means the chest, where the heart and the lungs are located. Of course, we know what is the face, but we have a face, and our face has certain features. All these features are based on the shape of these bones. The same the head. So every structure of our body is defined by these bones. They gave us this form, this shape when we walk. Remember, when someone has like kyphosis or this hunchback, we know already that they're kind of walking, bending forward, or they have problems with the bones of the legs. They can be walking like, I forgot again. I always forget these people that, ride horses. And that's something that I should know very well because I ride horses, but it's not that I have my legs that are bow legs. Anyways, so that's basically what it is. The bones support body weight. Remember, they give us the shape. They give us this framework because muscles will be attached to it. That's basically what it is. And that's why we have to be very careful because when we gain weight, these bones cannot cope with so much weight. It is too much. So we start having back pain, joint pain. So yes, they support the weight, but we have to have certain weight according to our height, our age. So very tough for certain bones to keep up with excess of weight. So that will cause some problems on the long run. So that's what is important for us to understand the functions of every single structure of our body, because we need to understand what causes medical conditions. Just the fact that, something is not, presenting the right way, or it is an excess of or deficiency of, then we're gonna have problems. As a protection, remember, bones protects internal soft tissue, like the skull protects the brain, the ears, the eyes. This will be the skull bones, the rib cage. It's like the chest bones, the shoulders, protects the heart, the lungs, blood vessels within, because there are blood vessels running through the chest to the heart and out. So bones of the pelvic, internal organs from reproductive and urinary system organs. So these organs are very important. So we don't want them to be damaged. For that reason, these hard structures, these bony structures protects all these organs that are internally located. If we attach bones, or if we attach muscles to bones, it's gonna be providing movement. Remember, if we don't have bones, it will be difficult to move. And if we have bones without the muscles, it wouldn't be difficult to move either, because how are you going to do it? So very important functions of the bones. So this is just some of the basic functions. We're not going to mention every single detail, but we kind of cover most of them, the most important ones that pertains to our program. So that's basically what it is. Any questions? Moving on. Here is again blood cell formation, remember, because it is so important. We need to repeat it. We need to go over again. Hematopoiesis. Hematopoiesis. What is hematopoiesis? Blood cell formation, blood cell production. It's the same. See, blood cell production occurs in the red bone marrow. So these are the questions for exam. What's the process of cell formation or blood cell formation called? Hematopoiesis. Where does hematopoiesis occurs? Red bone marrow. And if you don't have red bone marrow, bones. Because hematopoiesis happens in bones, but it's only on the long bones, on the larger bones. Which are these blood cells? Red blood cells, white blood cells, and platelets. So here it is. Red blood cells, white blood cells, platelets are produced within the red bone marrow. And this process of production, these red blood cells, white blood cells, and platelets is called hematopoiesis. So this is very, very important, once again, that we remember this, that we write it down so we can go over and review it again. Can you imagine without red blood cells or white blood cells or platelets? That will be fatal to us. And this is why when you go to the doctor, they order this test that is called CBC. Every single time that you go to your doctor, they're gonna order CBC. What is CBC? Complete blood count. What is complete blood count? I wanna see platelets, I wanna see white blood cells, and I wanna see red blood cells. Because I need to know whether they are balanced or not, whether you have enough, because we have ranges of red blood cells. You have to have certain amount of red blood cells, certain amount of white blood cells, certain amount of platelets. If you have too many, not good. If you have too little, not good. So you have to be balanced. So you have to be homeostatic. So you have to have homeostasis, balance. So that's why this is so important, because whenever you have a condition of your red blood cells, white blood cells, platelets, we are going to go and evaluate the red bone marrow. We are doing a process of hematopoiesis to see where's the problem. Where's the problem? How can we fix it? Okay, so let's enter now to mention all the bones of our body. Do we have to know all these bones? No. I'm going to tell you some of the bones that usually come out on exams because they are very, very common questions. And these bones are kind of, they are unique in certain aspects of our skeleton system. So first question that you're going to have is, how many bones there are in an adult person? 206 bones. Remember, there are 206 bones on an adult person. Adults are different than children. What about children? 270. They have more. Because as they are growing, bones should not be solidified yet. Most of these bones contains lots of cartilage, and cartilage later on becomes bone. And because we are in the process of developing and growing in height, they should not be solidified from day one. So most of the bones contains at the ends cartilage. And as the person grows, starts solidifying, this cartilage becomes bone. Otherwise, if we have just solid bones right here, solid bones right here, then we'll be shorted. Because what is it that's going to grow? Bone doesn't grow. What grows is cartilage. And most of the bones that we are born with are cartilage. Think about a little baby that was born. And the little baby stand up, walk? No, because they don't have bones yet. They have part of the structures that is bone, but most of the structure is cartilage. They are flexible. That's what the little kids have, the bow legs. They're not having straight legs. They have a kind of bow. The head start growing. The head doesn't stay the same size because they have a lot of cartilage. And as they start growing, well, then the bones start solidifying, meaning the cartilage start becoming bony until they stop. So when is these bones are going to stop growing? Or the person is going to start growing? When they reach certain age. That's it. They get to a certain age that from then on, we don't grow taller anymore. Because the cartilage within the bones have ended. That's how it works. So when you're a child, a baby, before you reach certain maturity, that you're no longer gonna be growing up, then certain bones that used to be cartilage becomes only one bone. We're gonna see those later on. That's why when you are a child, you have more bones than in adulthood, because certain bones that they were assumed to be bones, but they actually were cartilage, they fuse together and forms only one. So you eliminate kind of different little bony structures. That's how it is. So things that you have to remember, how many bones an adult has? 206. The skeleton, the human skeleton, is divided in two. The actual skeleton and the appendicular skeleton. So let's talk about the actual, what it's made of. The actual means the center. So pay attention to this because these are crucial for you to understand. Actual means center. It's like when we talk about the central nervous system, it's the center. So all these structures that you see here, see, that are kind of red, all these are the actual. These are the actual. What are the actual? The skull. The skull. The mandible, ear bones. Here are the mandibles. The hyoid bone. This is a little bone that is right here within the neck. We have the vertebral column. This is the vertebral column, which here we can see it attached to the head on the back, all the way down to the tailbone. Then the thoracic cage or the rib cage. See, all these bones. And all of them are lining up in the center. That's what's called axial. Axial means center. How many bones do we have here? 80 bones. There are 80 bones within the actual skeleton. But remember, we have 206. So that means that the balance, the rest is going to be the other parts. See, the other parts, everything else. So axial means center. All these bones of the center of the body. So we have 80 bones that make up the axial skeleton. Then we're going to talk about the other part, the other type, the other division of the skeleton. The appendicular. Here we have it. We know already what the appendicular means. Appendicular are Now, what means appendicular? Appendicular means attached to the side. See, this is the center. What is attached to the side? Arms, which are called the shoulders, of course. The shoulders, the arms, the fingers, or the hands. What is the appendicular? The hip bones and the legs and the foot. This is appendicular. How many bones do we have there? 126 plus 80, 206 bones in adults. That's how you need to remember this, because it's a lot easier to make it. I'm trying to make it very simple. Once again, very basic, so you understand. Now here we have the pectoral girdle. The pectoral girdle is nothing else than the shoulders. The shoulders has lots of bones right there. Upper limbs, arms, pelvic girdle, which is the hips bones, and the lower limbs, which are the legs. And in this appendicular skeleton, we have 126 bones. Okay, so any questions about the two divisions of the skeleton, the appendicular and the axial and the appendicular? Axial means center, and we know that it's made of the skull, the spinal column, or the spinal vertebrae, and the rib cage. The appendicular is made of the shoulders, the arms, and the legs. Remember that the hands are attached to the arms, so we cannot just single them out. It's the whole thing. The hips, legs, shoulders, and arms. That is appendicular. Appendicular means in the periphery. It's not in the center. It's outside. Let's imagine that the actual part of New York City is, we're talking about city, not state, is Manhattan. What are the appendicular part? Oh, Bronx, Brooklyn, Staten Island, Queens. See, they are surrounding the center, the actual part. So then we are going to be able to understand how this works. Now we're going to start talking about the axial. So we're going to talk about the bones of the skull, the bones of the rib cage, the bones of the spinal cord, of the spinal vertebrae. Then we're going to start talking about the shoulder bones, the arms and the hand bones, the hip bones, the legs, and the feet bones. That's how this works. So first we mentioned them as a group, and then individually we're going to be talking about these bones. Probably not going to be talking about every single bone, then we will never finish, right? We will just spend the whole time talking about the skeletal system. But we're going to mention some of them, and most importantly, their location. So we know which one is the skull, but then we're going to talk about not only the parts of the skull, because the skull has different bones, it's made of different bones, We're going to talk about the facial bones, because in the face, we have different bones that makes up the face. We're going to have all the bones that makes up the spinal column, spinal vertebrae. We're going to talk about every single rib that is here, the rib cage. We're going to talk about the shoulders, the shoulder bones, the arm. You see here we have one bone. Here we have another one, another one. Here we have a bunch of little bones. We need to talk about all of them. The same here, just because we say the hips does not imply, oh, the bone hip, that's it. No, the arm bones, that's it. Oh, that will be easy. But we have to mention each one of them, location. Then we're going to talk about them. They are long, they are flat, they are short, they are irregular. So that's basically what we are going to do with this chapter. So you can have a little better understanding of our skeleton system. Because we know about bones, but that's all we need. That's all we know. Sometimes we need to go a little farther than that because we're going to be working in a field that requires us to get to know these structures. So let's start with the skull. Skull has 22 bones. The cranium has or contains 8 bones. The facial skeleton of the facial bone contains 14 bones. See? So 8 plus 14 equals 22. Are you going to be asking the exam, oh, how many bones are there? No. Remember, you're going to be asking general how many bones do an adult person, that's an adult person, have? 206. Anything else individually, you're not going to be asked about some of these things. But we need to put all these 206 bones together, and most of them we're going to mention. Some of them will be very important. Some of them, well, we're not going to use it much. But for your own knowledge, it's very important that we know them. Let's start with the frontal bones. So frontal bone, this we are very familiar with because this is the forehead. All this bone is the frontal bone. See? The frontal bone. The forehead is the frontal bone. Frontal sinuses. Yes, right here we have some sinuses. There's some space right here. When you develop sinusitis, it's because this space underneath the skull fills in with secretions, with mucus. And it creates pressure inside. And because this mucus stays there too long, it rottens. And if it rottens, bacteria grows there. If bacteria grows there, we're going to develop an infection that is called sinusitis. So that's what is important to know about this. We have sinuses here, we have sinuses here, we have sinuses here. Those are the most important sinuses because there is a condition called sinusitis. And a lot of people suffer from this. So we need to understand why is this going on? Not that we're going to explain diagnosis. No, it's just to let you know. Now, when you go to the doctor and you complain about pain in this part of the forehead, right there in between the eyebrows, then you know already that you have sinusitis. Or you have pain right to the sides of the nose, and you pinch right there and you kind of press, and it hurts. You have maxillary sinusitis or frontal sinusitis. So this is the frontal bone. Remember the forehead. So easy, right? Frontal head. That's it. Frontal bone. Parietal bones. Parietal bones, there are two. See, only one frontal. You have one forehead. We don't have two. But we do two parietal bones. This right here is the parietal bones. These are the ones that make up the roof of our head. Here there is a division. So we have one on the right and one on the left. This is the right parietal, the other one on the other end. So we have two. See, sides and roof of the cranium. There is a sagittal suture called the coronal suture. So this is the coronal suture, this one. So divides the two parietal. So that's basically how it is. So for you, just there is one frontal bone, two parietal. If just in case you have a question when they ask you, okay, the forehead is which one? Oh, the frontal bone. The roof of the head is which bones? Oh, the parietal bones. So just like that. Occipital bone. Well, the occipital bone is only one. Occipital is the backbone, the bone on the back and the base of the skull. This hole right here, this space is where the spinal cord attaches to it. The spinal column is attached to it. Back of the skull, base of the cranium. This is the base of the cranium. This is the foramen magnum. This hole right here is called the foramen magnum. Here it is. It is divided from the other bones of the skull by the lumboid suture. So these sutures that divides right here, the one that I marked from the other parts of the bones of the cranium are called the lumboid suture because these are different bones. Remember, when we are fetuses, when we are babies and newborns and infants and all this stuff, we have cartilage in between these bones, in between this bone and this bone and this bone, every single, we have cartilage. So as we grow, these start growing, the cranium start growing. The brain inside the cranium start growing. We don't stay with the same size of the head or the arms or the legs. We grow, grow, grow. But if it was like a fixed cranium, how it's going to grow? And what about the brain that is growing, but the skull is not allowing it to grow? That will be horrible, right? Because the person would die because the brain doesn't have more space where to go. So this is the occipital, the back of the skull. Temporal bones. So we have two temporal bones. We have two temporal bones. These are the temporal bones. See? Right here. So I'm going to use a different color right here. There is one on the right side. And this one on the left side. Two temporal bones. Now, this is the bones where the ears are located. Very important. Sides and base of the cranium. It forms a little bit the base right here on the back. External acoustic. Remember, acoustic means ear sound. Now, meatus means opening, this opening of the ears for the acoustic, for the sounds to pass through. The mastoid process is located right here, is this protuberance right here that we see. This is very important bone. So this protuberance right here, this is right here on both sides. This is the mastoid process. So again, very important parts, but for now, you just need to know this is the frontal, this is the parietal, this is the temporal, this is the occipital. Now we're going to go with the sphenoid and the sphenoid bones will be next. Sphenoid bones is one. Base of the cranium. So it's right here inside. See? Sphenoid. It's right here in between. I'm sorry, it's in between all these bones. Here is because this is inside. This is not on the outside. It's just that it's showing it because it's difficult to show it inside. Here is where we have the sella turcica. Sella turcica is like a little chair where one of the most important glands of the endocrine system is located. So we will discuss that when we get to that chapter. For now, no worries. Usually they don't ask about this. We have the sphenoid sinuses. These are not so common problems. It's the maxillary and the frontal sinus is the one that give us trouble. So for now, take-home points are the sphenoid is just one of the bones of the skull. The most important part of this is for the sella turcica that is located there. Because here is where a gland that is called the master gland, the pituitary gland, will be sitting for protection. But they're not going to ask about this. Now, last but not least, the ethmoid bone. There is one. And this is also located right here within the orbitals. It's in front of the sphenoid, which is here, wall of the orbitals, but within the orbitals. Not, see, the other one is right here inside. This is right here to the wall of the nose. That's orbitals. The hollow space where the eye is located, that it is the wall with the nose. Do not worry about these bones. They never ask about these bones. They ask about the frontal. Also, well, when we talk about the frontal, the parietals, the occipital, the temporals, good enough. The other ones, usually they don't ask. And exams, they don't ask any of these. I will let you know which ones they ask. These are the major sutures of the skull or the cranium. We mentioned them. So we have the coronal, which will be this one. Remember, this one that separates the frontal from the parietal. The sagittal, this is the one that separates the two sides of the right and left parietal. Squamous, this is the one that separates here the temporals from the parietals. The lomboid is the one that separates the parietals from the occipital. If you ever ask, you will be asked about the sagittal. Because remember, in medical terminology, sagittal means sides, dividing the body into sides. Here is dividing the skull in two. Right side, right parietal, left parietal on the other side. Sagittal. Anything else? If, not saying that it will be something that they must, but if they ask, that will be the only suture that they going to ask. Remember, sutures are this place when these cranium bones connect to each other. That's basically what it is. And before we reach the adulthood, these sutures are cartilage. Because as the brain starts growing, then the cartilage becomes bony. Then disappears the cartilage. There is no more cartilage here. So that will be the sutures. The facial bones. We are going to have these bones. There are two maxilla or maxillary means these bones of the maxilla, the ones that holds the upper teeth and the lower teeth. This is one maxilla superior, and this is the inferior maxilla, or the mandible, the upper jaw. See, anterior roof of the mouth. Do not worry about these things. You just know that this is the maxilla, upper and lower. Upper is the one that holds the upper teeth, and the other one, the lower teeth. That's it. Getting closer to one of the questions that you may have in your exam. So this is the maxilla. The zygomatic bones. Now, what are the zygomatic bones? The zygomatic bones are the cheekbones. So cheekbones, this right here. This right here. These are the zygomatic bones. Some people have very pronounced cheekbones, some others not so much. See, the shape of the bones can give you the shape of your face. The lacrimal bones. Lacrimal comes from tears. This is a Latin term. Lacrimal, lagrimas, tears. So this is where we have some little glands that produce the tears. That's it. Nobody asked about this anyways. The nasal bones. Well, the nasal bones are the nose, the bones that makes the nose. But it's only this little piece right here. We have two on both sides. Because here we have the bridge. We have one side and the other side. But it only goes up to here. Because everything else that we have in the nose is cartilage. But cartilage is soft tissue. So when we die, the soft tissue destroys very easily, dissolves. So the bone part stays for the longer part. That's why this part of the nose that has the cartilage, the end, the one that gives us the shape of our nose, it can be fixed, it can be easily fixed because it's cartilage, not bone. So if your nose is crooked, is deformed, it is broken, blah, 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 it can be fixed easily because most of these nose bone is cartilage. No worries about these bones, just for you to know, because we need to cover all these bones. The bomber bone, the bomber is this bone right here. This bridge that separates the right nostril from the left nostril. So that's called bone. This is where the cartilage is attached to it. And it can give the shape to the nose. See, along midline of the nasal cavity. So this is the one that forms the septum of the nose. So this part that separates the right nostril from the left nostril. Nobody asked about that. So just for you to know, this is an exam question. The mandible. The mandible is the lower maxilla. It says the lower or the jaw bone. Remember, the mandible, the jawbone. What is so important about the mandible? Because the mandible is the only movable bone in the face. Remember, the mandible, which is the lower maxilla, is the only movable cranial facial bone. We move it when we talk, when we chew, when we eat, when whatever we do. This is movable. So that's what is important because it has a particular characteristic. It moves. It is movable. The other bones, they don't move. Your cheekbones, they don't move. Your upper maxilla doesn't move. But this lower jawbone, that it moves. If it didn't move, we're going to have a problem. We wouldn't be able to chew, to talk, to do anything. So the mandible or the jawbone, please know this, put a mark right there because this will be question for exam. Okay, I think that has been enough for today. We are going to stop here because we have covered a lot. And I don't want to kind of, put all these information on your brain. You're not going to be able to process it. It's a lot of information, even though if I have summarized most of this, I just want you to kind of absorb, digest a little bit some of these terms and structures. Many of them that we have already covered. So I don't want to go and feed you with more information because then you will get impactation in your brain with this information. So we're going to leave it here for today, and tomorrow we will finish this chapter, okay? I mean, if you are agree, otherwise we continue. I have no problem with that. So you wanted to continue? You wanted to finish this chapter, or you wanted to just stop now? It seems like you want to continue. No problem. I'm gonna continue.
No, no,
Well, you guys not talking.
no. I was gonna say that. Yeah, we should stop. It's already 54. I mean, yes, 54.
Yeah, not only because of the time, it's because it's
So
been a lot of information that I have tried to
yeah.
do. So let's this information to be digested overnight, and tomorrow is gonna be another day, and tomorrow we continue with the rest of this chapter. All right?
All right. Good night.
Okay.
Good night, everyone.
So good night, everyone. See you tomorrow. Thank you so much for attending the class. Tomorrow we meet at the same day. If you guys have any questions, regardless whether the new ones or the ones who are currently in the class, please let me know. You have my email, okay? For those who have not turned the exam yet, please, you know who those are. Time is running out, so please send the test. Thank you. Have a good night, okay? Talking about the medical terminology test. All right, so good night. Get some rest.